A 75 kilogram person is lifted up in an 1100 kilogram elevator. If the person is lifted 15 meters in a time of 8 seconds, how much power is delivered by the elevator? I'm going to start this problem the same way we start most of our problems. Draw a picture. So here's the elevator. Got a person in the elevator. The elevator is going to be lifted up 12 meters. Next thing we want to do is write down what we know. Well, it says a 75 kilogram person. So that's the mass of the person. And that is 75 kilograms. Is lifted up in an 1100 kilogram elevator. So that's the mass of the elevator. The person is lifted 15 meters, so they're going a distance of 15 meters in a time of 8 seconds. So it takes 8 seconds. The change in time is 8 seconds. And the question says, how much power is delivered by the elevator? So we're trying to figure out the amount of power. All right, so let's go ahead and look at our equation sheet. We know power is how fast you do the work. So it's the work divided by the change in time, how long it takes you. Okay, so I look over at my givens, got the time. I do not know the amount of work that's been done. Look at my equation sheet again. Okay, work is equal to the force times the distance times the cosine of the angle between the distance and the direction the object travels and the force that we are dealing with. Now, this equation leads me to realize that I also need a free body diagram because it's got a force in it. I need to know what force I'm talking about. In order to do that, I need to draw myself a free body diagram. So here's the elevator and the person. Forces acting on them. One, the gravitational force acting straight down towards Earth's surface. And two, an applied force that is pulling them up. Okay, so I've got a couple forces there. I want to know how much power is delivered by the elevator. So I'm talking about the force that's delivered by the elevator, which is going to be this applied force. So I'm going to use a little subscript A to denote that. So now I go ahead and I look at this equation. Well, I don't know the applied force. It's not written down over here. So I'm going to need to find it. So I look at my free body diagram. The applied force is in the y direction. So I'm going to use that information. So I'm going to say the net force in the y direction is equal to, and then we either know it's equal to the mass times the acceleration or 0. Okay? In this case, when we travel on an elevator, typically you start moving, you go at a constant velocity, and then you stop moving. So we're going to say the elevator in general is traveling at a constant velocity while we're on it. So since it's traveling at a constant velocity, we are going to say the net force in the y direction is equal to 0. Remember, the net force in the y direction means you should add up all the forces in the y direction. So I look at the picture. I see two forces going in the y direction. Gravitational force pointing downwards, so I'm going to make that negative. And I'll add that to the applied force, which is pointing upwards, so we'll keep that positive. Now I can start substituting in. 0 is equal to, unfortunately, I don't know either of those. Well, our objective is to find the applied force, so hopefully we can find the gravitational force another way. Look on your equation sheet. The gravitational force, also known as the weight of an object, is equal to the object's mass times the gravitational field constant. Well, in this case, we need the total mass because the elevator is not just lifting the person, it's lifting itself and the person. Okay, so we need the total mass over here. So add those two together, we'll get 1,175 kilograms. Now we can substitute in 1,175 kilograms times 9.81 newtons per kilogram leaves us with a gravitational force of 11,526 and 7/500 newtons. Substitute that in over here. So a negative 11,526 and 75 hundredths plus the applied force. Add that to both sides, and we end up with the applied force is equal to 11,526 and 75 hundredths newtons as well. Now we can substitute that up here. So the amount of work that was done is equal to 11,526 and 75 hundredths newtons times the distance, well, the person in the elevator traveled 15 meters, times the cosine of theta, where theta is the angle between the force and the direction. Well, the force is pointing upward and the elevator moved upward. So that angle is 0. Cosine of 0 is 1. Go ahead and multiply this together. We find that the amount of work done is 172,901 and 25 hundredths joules. And now we're ready to find the power. Power is how fast you do the work. So I can go ahead and substitute in. Power is equal to the amount of work, 172,901 and 25 hundredths, divided by how long it took to do that work, 8 seconds. Divide, and we will get, it took 21,612 and 66 hundredths watts of power.